Alright, so here is a little tip to work through some series problems. So now that we're all done learning all of our tests that we're going to use for testing convergence for series, these are step-by-step instructions on how to kind of figure out what test to use for each series. So this is in your packet. So if you go ahead and look at those, you can write those down, or if you haven't already, print these out. And the same thing with this next part. So this is a list of all the tests that we've learned. So you'd probably want to have this handy, either writing it down or printing it off. Be extremely helpful for you to be able to look in one location to determine what test you're going to use. Because when you're asked to see if it converges or not, it's not going to tell you what test to use. You're going to have to figure that out on your own. So these are a couple examples of when you would want to use it, or and the general test in itself of what you need to look for. So let's go ahead and try a couple of these. We have some problems where you're going to have to determine what test you're going to use. So before I even start on each problem, what I want you to do is pause the video. I want you to look at each one individually as we're going through these, and I want you to try to determine what test you're going to use before I say it. Alright, so number 5, we're going to look at this, and we're going to do the nth term test. So nth term test means I'm taking the limit as n approaches infinity of the series. So we're just n minus 1 over 2n plus 1. Okay, so if we run the limit, we can do L'Hopital's, or we just see leading coefficients. This is going to give us a 1/2. So 1/2, remember with the nth term test, it has to equal 0 for it to possibly converge. If it equals anything else, we know it diverges. So this does not equal 0, so diverges by nth term test. Okay. It's probably the one you're going to always want to start with, unless you see something right off the bat that you want to use. So number 6, we're going to do limit test, or sorry, integral test. Integral test, we're going to want to set up the integral from 1 to b. I'm taking the infinity out because that's improper. Switch everything to x's. And we know we're going to b, so we know we're going to run the limit of our integral. I'm just going to save that for the end, so instead of keep writing it. So we want to integrate this. So we have u substitution here. So we can make our u x cubed, because we know the derivative of that is x squared, something with x squared, so 3x squared. So we're going to have to pull 1/3 out front. So make sure we're able to do these integrals. So I would suggest pausing and kind of working through them with me as we go, and make sure you're on the right track. So this is 1/3 e to the negative u. Well, we know that's u. Okay, so if we were to take derivative of this, we know that power would come down, or the derivative of the power drops down, and we get that. So we're evaluating that from 1 to b, and we are running the limit of this as b approaches infinity. And we end up with, let's see, plug in b and we plug in 1. We end up with 1 over 3. I'm going to move the e into the denominator because it's on negative power. So e to the b cubed oh, sorry, this is negative, by the way. So this is negative. So we're adding, we're subtracting a negative, so we're adding. And then 1 over 3 to the e to the 1. So 3e on the bottom. Alright, so we run the limit of this, and the first term is going to be 0, approaching 0. And we get 1 over 3 to 3e. Which, if we plug this in the calculator, we get a value. So this is going to converge. Remember, if we get a value, it converges. So it converges by integral test. Looking at number 7, we should recognize that this is a geometric series because we have a number raised to the power of n. And well, not equal, we can just say, so our r is e to the third, or e divided by 3. So e divided by 3 is less than 1. So we know this thing, this series converges by geometric series test. Alright, so hopefully you got that. Remember, we're pausing through these. You guys are trying to figure out what test you're going to use and trying to work through it on your own. So number 8, we look at number 8. We're going to want to use the limit comparison test. So limit comparison test, I'm going to use 1 over n. And we know 1 over n diverges. Okay, so that diverges by a p-series test.